The rapid pace of progress in electronics means that even if you've been selling cars for years, you may not be totally familiar with all the advances that have been made. The fact is that today's children often know more about electronics than their parents. After all, they've grown up with video games and computers. And in a few years' time, they'll be your new customers, and they'll be asking a lot of questions. So you need to keep up to date with technology. Isn't that true, Professor?
Perfectly true. But let me put your mind at rest. Even though I'm a university professor, I'm not about to deliver a lecture, or even try to explain Edison's thermionic effect. Instead, I'm here to help you become knowledgeable and informative about the selling features and customer benefits of electronics on Fiat vehicles. We can start with a general observation about electronics and an inherent advantage over electromechanical systems.
What's that, Professor?
With electronics, there are no moving parts. By way of contrast, just look at this relay. It has a hinge, a spring, and contacts, with adjustments and settings that inevitably become inaccurate with wear and tear. On the other hand, this is a diode, or semiconductor based on silicon, which does the same work as a relay. There's no middle way with electronics. They either work or they don't. In other words, a unit that doesn't work is eliminated during the production cycle. The ones that pass the test are reliable in all operating conditions. That's why electronics are always preferred wherever dependability is essential. From planes to missiles to satellites and even sophisticated medical equipment.
Okay, there are 3 questions about electronics I'd like answered. What functions do they serve? Why can't we do without them? And what advantages do they bring? For example, whenever electronic ignition is mentioned, owners expect to see something futuristic. Then when they lift the bonnet, they see the familiar brown distributor cap and its 5 leads. So what's new?
The old type of ignition was by breaker, and a tiny switch called a breaker arm, providing the discharge, and timing via a camshaft. Today we speak of breakerless ignition, which means what it says. Our illustration shows electronic ignition. The mechanical breaker arm is replaced by an electronic control unit that regulates the timing, amplitude, and intensity of the pulse. This system solves 80% of the problems you get with traditional ignition. For one thing, you no longer need to clean or change those infamous points.
Now there have been further developments in electronic ignition, haven't there, Professor?
Yes. Today there are 3 devices that offer other advantages too, namely digiplex, monoplex, and microplex. What these systems have in common is a series of ignition advance curves memorized by a little computer that constantly processes data and gives an instant readout of the optimal advance. This results in improved engine efficiency, better fuel economy, less pollution, and, essentially, more enjoyable driving.
All these systems still appear with their old guise, the distributor cap. In future, though, electronic timing will look a lot more futuristic. Something like this. Now let's look at the cutoff device. It's used to conserve fuel when the accelerator pedal is released and the engine, driven by the road wheels, takes in fuel from the idling jet or the injectors.
The cutoff is applied to both the carburetor and the injection system. It works exactly like a tap that cuts off the petrol. However, to prevent the engine stopping at 1500 RPM or lower, the fuel flow returns so that the engine is self-supporting at 800 RPM. In other words, it's a system for saving fuel in town or on the motorway, such as when you start to overtake and then give up.
Tentare un sorpasso e poi rinunciarvi.
Now let's turn to the knock sensor. On high compression engines like turbos, the knock sensor on the control unit acts like a microphone by recognizing the slightest knock and intervening to reduce the advance.
The knock sensor, indicated by that flashing light on our electronic car, means that the engine can work very close to critical but optimum areas. This results in optimum economy and power, with no risk of damaging or even worse, melting the pistons. You can see its location on the drawing.
Now we'll turn our attention to the Overboost. This comes into play when you want an extra burst of power without changing gear. For example, when you're overtaking or in similarly critical maneuvers. The Overboost is what you can see flashing now. Let's hear what Michele Alboreto has to say about it.
Will you tell us about this Formula One development?
Yes, the Overboost is a system that gives you extra power in certain situations. We use it in racing
When you need extra power?
Yes, even more power. Ours is a manual system. We have a knob we turn, but this is an automatic system.
Yes, this is automatic, and it increases torque by 12% for 30 seconds. So you can use it to overtake or in emergencies. You trigger the Overboost by pressing the accelerator to the floor. A timer limits its action to prevent over-revving, and the power increase is 15%. Normally, not all the exhaust gases flow into the turbine, otherwise the engine would be damaged. However, when the Overboost is activated for a few seconds, all the exhaust gases flow into the turbine and the induction air is compressed, making the car leap forward.
Professor, if you don't mind me asking you a rather basic question, how would you describe the function of a carburetor?
We might describe it as a Venturi tube in progressively smaller sections, which increases airspeed and reduces pressure. Petrol enters through the spray nozzle and is atomized. Increased air is matched by increased petrol.
Yet, over its long history, the carburetor has always presented operating difficulties. And today, with the problem of noxious exhaust emissions, they're even greater.
That's why we've gone over to electronic injection. It's quite easy to see what's new here. The inlet manifold has gone and been replaced by aluminium and rubber pipes. The system works like this. Air enters an induction tract leading to the cylinders, and a series of sensors measure air temperature and pressure. On this basis, the control unit calculates how much air has passed and responds by supplying precisely the right ratio of petrol. An injector sprays fuel into the manifold upstream of the induction valve.
And now we've seen how it works, let's remind ourselves of the advantages of electronic injection. Higher specific power, less fuel for comparable performance, higher torque at lower revs, easy starting, greater engine flexibility, immediate pickup.
A further step forward is represented by integrated injection. As the term indicates, the injection function is integrated with electronic ignition in a system called IAW, as fitted on the Chroma 2000 IE. The advantage it brings is an optimized performance, consumption, emission ratio.
Thank you, Professor. Now let's turn to something else and hear what Giancarlo Baghetti has to tell us about another clever fuel-saving electronic device called Citymatic.
Have you ever thought how much petrol you use just standing still, waiting for the lights to change, or waiting in a traffic queue? Well, Fiat has. And that's why they devised Citymatic. Let's see how it works. It's dead easy. and you can switch the system on or off at will. Supposing it's switched on and you approach traffic lights. They change to red, so you stop. Put the gear lever into neutral and the engine stops. Then, as soon as the lights change to green, you depress the clutch, engage first gear, and the engine restarts automatically as you move the gear lever. As you see, it could hardly be easier. I've tried it in town traffic at peak commuter times, and my fuel consumption fell by about 17%. Not bad, eh? Just think how much money you'd be saving in those long waits at the lights or in a traffic jam.
As we've seen, this is a highly useful system that can save up to 20% of your fuel. Then think of the advantages to the environment with the reduction in exhaust emissions. However, in this quick survey of the world of car electronics, we're now going to have a look at anti-skid braking. This is where electronics become a positive aid to safety. Let's see it in action.
In sudden braking, you always risk overdoing it and locking the wheels. The resultant loss of grip may provoke a tailspin. Now look at this. The anti-skid system has 4 sensors that measure individual road wheel speed and differentiate the braking force. This is a highly intelligent system that feels how fast the wheels are turning and brakes accordingly. As soon as the sensor feels that the wheel is about to lock, it alternately reduces and increases the pressure. This system shortens braking distances, especially in the wet. You can even brake reliably with 2 wheels on a dry surface and 2 on mud or snow, without skidding. So the anti-skid system dramatically improves safety.
Now let's see how electronics improve ride comfort. Car suspensions are designed for fully laden conditions, but 90% of the time the car is carrying only 1 or 2 people, which affects ride quality. Again, electronics offers a solution: self-leveling suspension. In the case of air suspension, if the back of the car is laden, the rear end lowers because the air is compressed. So, all we need to do is add more pressure through a pump and the car returns to its normal attitude. But who opens the pressure tap? A sensor feels attitude variations and acts like a tap by increasing pressure in the rear dampers and bringing the car back to the horizontal.
The result is extra comfort, especially with independent suspension. As a result, suspension angles are reduced. The car's drag coefficient is improved, and you no longer need to adjust headlamp beam angles.
Now let's talk about the more visible aspects of electronics, the ones that enhance prestige and constitute a selling feature. I mean the instruments and what the driver sees ahead of the wheel. Let's start with the check control panel.
The instrument incorporates an electronic control unit and a microprocessor. It checks the efficiency of numerous vehicle functions designed to ensure passenger safety and vehicle efficiency. Specifically, oil level, brake wear, light bulbs, and door closing. The trip computer is a system that supplies information about your journey, such as fuel consumption and average speeds. An electronic control unit processes the data and tells you all sorts of things. Average fuel consumption, remaining distance to travel, average speed, elapsed time on the road, date, ambient temperature, fuel consumed. Fiat has also launched the widespread use of certain highly innovative electronic instruments like the liquid crystal displays on the Uno Turbo, for example.
With Professor Piggini's help, we've tried to give you practical and easy-to-follow information on the electronic content of current and future Fiat cars. Information you'll also find in this booklet.
The world of electronics is fascinating, and we all need to be more familiar with its terminology and technology as its influence on future cars continues to grow.
So goodbye and good selling. And remember, we need to keep abreast of technology to compete effectively.